Fine. So basically, like suppose you are given an array, you want to kind of go over all the subsequence and want to do something. So for a given array, so let's say you are given an array of length n. So how many number of subsequences would be there? Subsequences are like you can, so you go from left to right, you can skip elements. So substring has to be continuous, but subsequence don't need to be continuous. That's the main difference. So how many subsequences are there for a given array? 2 power n, because you can essentially select each element. For each element, it can be the part of the subsequence or need not to be part of the subsequence. So let's do one thing. Let's quickly implement subsequence using recursion. Then we will see. So suppose I want to print the indices of all. So suppose my array is, let's say 1, 2, 3, 4, and I should print all possible subsequences, So those would be subsequences of length 1, 1, 2, 3, 4, and then subsequences of length 2, which will be 1, 2. Let's keep it slightly less. So 1, 2, 3 of length 1, of length 2 would be 1, 2, 1, 3, and 2, 3. And of length 3 would be 1, 2, 3. The total, how many are there? 3 in the first one, 3 in the second one, and 1 in the 3, 3, 6 plus 1, 7. But formula was saying 2 power 3, which is 8, because formula was counting empty subsequence also. So 7 plus empty subsequence, like don't take anything, then it will become 8. Fine. So how do we print this thing? So suppose I have int n, which will denote number of elements. So here n equal to 3. So I create a vector int a of size, let's say n, and then for 0 to I plus, let's say ai is I plus 1. Now I have to apply recursion. So let's say I go in the recursion and suppose I pass this vector int a, let's say I pass by reference and int position, and let's say this is my vector int of subsequence. So I will call this with recursion a starting position 0 and vector int subsequence is, let's say, empty vector. So if let's call this position maybe index. So if index is equal to a dot size, then let's say we just print this subsequence. So let's call debug subsequence. Otherwise, you can decide to take element at the index, or you can decide to take a of index in the subsequence, so which is recursion of. So first so there will be 2 cases, either you take this element or you don't take this element. Let's first write don't take a of index. That would be recursion of index plus 1, subsequence will be same. And let's say we take it, so index plus 1, subsequence would be, we will have to append subsequence a of I, a of index to the subsequence, so it will become this. So this is my entire code. Let's try calling it for, let's say, n equal to 3 and see what is the output. Okay, this compiled and let's see. So it prints empty subsequence, then 1, 2, 3, then 2, 3, and 1, 3, 1, 2, and 1, 2, 3. So if I want to find total size, this is 3, 3, 6 plus 2, 8. So suppose I try for n equal to 4. So it has printed all of those. Suppose I try n equal to 16. How much is 2 power 16 by the way? For n equal to 16, how much is 2 power 16? It would be, let's find it, 2 power 16. It's 16,536. So let's say we, okay, I think it's printing. Anyway, so this is like our basic code. Does everyone get this part? How we are doing this recursion? How we are kind of printing all possible subsequence? This is very critical. So, you are basically passing what is your current index, what subsequence you have built, and you iterate over that. And whenever your index reaches to the size, you don't do anything. Otherwise, you do the recursion, and there will be two cases: either you take this element as a part of your subsequence, or you don't take your element. So this one is don't take. Subsequence remains same. This is when you are taking, then subsequence changes. So is everyone clear with this part? This one is like very important sort of recursion. This one. So, so suppose someone asks you, key, instead of printing subsequences, print the, so suppose question is following, given an array A, take all possible subsets and find out the possible sums. Yeah, find out sum of each of the subsets. Find out sum of each of the subsets. So subset is same as like subsequent. Subset is like set of elements. So suppose in this case here, instead of finding 1, 2, 3, you print the sum. So here instead of printing 1, 2, you print its sum. So instead of 1, 3, you print 4. Instead of 2, 3, you print 5. Instead of 1, 2, 3, you print 7. So suppose someone is asking you to just print that sum. So instead of this subsequence, you will pass just a variable. Let's call it sum, and you will just print sum here. And here you will go sum, and this will become sum plus. And let's, instead of calling this recurse, call it recursum. And now you can try the same code. Instead of recur, we will call it with recursum, and here we will pass G. And so then you will be able to see, instead of printing the numbers, it is printing the sums, corresponding sums. So you can see key for n equal to 3, it's printing sums. So is this clear, this part? And how do you print sum? Suppose someone asks you find out product of each of the subsequences. So instead of sum, you will take product here. So this technique is really important and it will help you in solving multiple questions. So if you guys have some suggestions for questions, let me know.
I mean, there is one in chat. Someone has asked.
Can we print in this format? 1, 2, 3,
Yeah.
6. Yes, we can print. So if you want to do in that way, you need to maintain your subsequence as well. So your subsequence as well and sum as well. So subsequence will become subsequence. And here you will do subsequence to say of index. And you will pass subsequence. And you can pass vector in here. And while printing, you print your subsequence and sum. So maybe, yeah, so subsequence is empty, sum is 0, subsequence 3, sum is 3, 2, 3, 1, 1. One more thing is you don't sum as a parameter, you can calculate sum here as well. So suppose I'm not taking this one as a parameter. So you can just do this, Let's not pass sum. I can calculate sum here. So sum is equal to 0 for int x in subsequence, sum plus equal to x. I can do that as well. What's the problem? Then I don't need to pass this here separately. Fine. So whenever you need to figure out what things should I pass, you will get this idea. For example, here you don't need sum separately. You can calculate it using your subsequence. So this is one idea. The other idea using so there's one other way of doing the same thing, which is following. Void, let's say find all subsets, and let's say vector in A. Suppose for this given, I of doing to do iterative. What you do is integrate your subset by bits, basically your subset by bits. So suppose
somebody has a question. Actually, just check your chat.
What if you just use one vector for all subsequence? One vector for all subsequence. You can like maybe create a vector of vector and push your subsequence into that. Because your subsequence is a vector of int. So maybe you can create another vector of vector int and you can kind of does that answer your question? Like
hello?
Hello?
Hello, am I audible?
Yeah, you're audible.
Yeah, I'm saying that if we pass the reference this subsequence vector, then what will happen?
Here you want to pass reference this way.
Yes.
Okay, let's try this. And we'll have to create V. And let's pass V. Fine. And let's see whether it does right thing or not. So you see that it's not doing the right thing. Try that equal to 2 and see does 2. So you can see that for n equal to 2, it is taking 2, 1, 2. For n equal to 3, you are saying you see that it's taking because you are just modifying is so what is happening? So you are passing the same subsequence in your entire recursion. So what will happen that whenever you do this addition, this subsequence will get updated. And because you are passing it by reference, so its value will change. So if you pass like 10 entries, it will push 10 entries. So initially you pass 3, then you pass 2, then you pass 3, then you 1, then you print 3, then 2, then 3. So it will modify the same subsequence in all function code. So you don't want to do that. You want to pass. So if you want to modify this subsequence across your recursion calls, then you would pass it as a reference. Otherwise, you shouldn't pass it as a reference. Do you get this idea? So when you pass it as a reference, whenever you are doing this operation, this will be applied and the corresponding subsequence will change. So if you see it this way, so suppose I started with 0, index was 0, and this was an empty vector. Then you go to recursion and you do the first thing, which is don't take. So this will go to, so this was your A, this was your 0, subsequence is empty. Let me just, this is your starting state of recursion. You passed A, you passed 0, you passed vector end, fine. And then we did this called recursion. So A will remain as the same, index will become 1, and vector will become empty, which is fine. Then it will go to same call, and it will call to A with index 2, vector and still being empty. And in this case, index becomes A dot size, so it will just print subsequence is empty, which is empty, and 0. So at this place, it will print empty and 0. Fine. Is that clear? Now what happens? Let's go to this side of recursion call. So you will modify your subsequence. So A1, this will go to A1, and your vector will store this quantity, A of index. So A of 0 is, let's say 1. Then from this is fine. From this, you will call to A2 and don't pick anything. So there also you will pass 1. So what is happening is this reference, so suppose you went here in recursion call and you did A2, 2. You appended, let's say 1, 2. So what will happen ki this subsequence, whenever you do an addition, this addition will be applied globally in the sense. So you can understand the same code as following. So instead of passing it as a reference, you pass it as a global variable, let's say. And then you do the same thing. Will your code be correct in that case? So your subsequence is now a global variable. Will your code be correct? Your code will not be correct because if you are, so you can see clearly here that my size of subsequence has become 336 and 17. Because whenever I append, the size will increase because this is a global variable. That's why we will have to make it a local variable. And when you are passing it as a reference, you are more or less making it a global variable in that sense. Because if you modify that thing, it will modify for the entire if you modify some reference variable, it will be modified for everyone. But if you just modify a local variable, it will only be modified in the local scope. Do you get this idea? So he will just append on the previous list. You can pop back after we are done. So what strategy you are trying? So you pass vector and subsequence and subsequence. So you post in subsequence. Then you are at this point you are saying subsequence dot pop. Is Is what you're saying, Rosie? Is this what you're saying? Okay, let's try this. This one worked for 2. Let's try it for larger. So for 3 also this works. Let's try it for 4. So you can just check your strategy by trying. Seems to work for 4 as well. So this should work properly. And figure out reason why this should be working. Because whenever you are kind of exiting from your recursion call, your subsequence is at the correct level. So if you don't do this, so essentially what will happen, it will go deep in the stack. So suppose you want to track some possible subsequence. So it will go deep in the stack, go till that subsequence, and then it will pop and come to a particular position. So if you want to pass by reference, make sure you do this pop back operation. Otherwise, your code will not be correct. So this should work. Fine. So this strategy, this is like a neat trick in some sense, which comes handy at quite a place, which is useful at places. But if you don't want to do this, you can just push subsequence, and rather than keeping it as a reference, just keep it simply. You just pass the subsequence, don't keep it as. So whichever is like simpler, make sure you implement that one, because don't pass too many things by reference, because then you lose track of correctness. It becomes slightly difficult to prove correctness here. If you are just passing it without reference, and if you are doing this, you know your correctness much better. If you write this code, let's say, you are not passing any reference, here you can argue in much better way that your program is correct. You are just passing A as reference, and you are not modifying this array A. So this way you can reason better about your code, that your code is correct. Is that clear? Okay, try use. It's useful to backtrack. We will see some problems where this will come out to be handy. But in general, like if you can do something without reference, it's a good idea to do without reference. But if you cannot avoid using reference, do it. So let's solve some maybe one more problem, and then we will see. Does anyone has any doubt till now? At least everyone got this idea. Okay, how do you do this recursion? Should I proceed? So this was our one, and let's go to problem 2. So suppose now someone asks you print k combinations. So given an array again, array A and an integer k, print all k combinations of given array A. So let's say A is 1, 2, 3, 4, and someone says k is equal to 2. So you have to print all possible 2 combinations of A. So number of ways to select 2 elements in this. So that would be 4C2. So you can see 1, 2 is one way, 2, 3 is another way, 3, 4 is another way, 1, 3 is another way, 1, 4 is another way, and 2, 4 is another way. How many total does it become? 3 and 3, 6. Is it fine, or are there more? Are there any more ways of for k equal to 2, or is it fine? Does everyone get the problem? What is a k combination? K combination is number of ways of selecting elements, or number of ways of selecting subsequence whose size is k. So in case, find all the subsequences whose size is k. So in this case, all the subsequences whose size is 2. So you can solve this problem pretty much like the other problem. So this problem you can just directly solve using just directly by the previous code with some small modifications. Fine. So let me at this point tell you another technique of solving these subset problems. The technique is called so that is something related to bitwise operations. It's not that complicated. I'll try explaining you. So question is how to generate all possible subsets using bitwise operations. Essentially, so suppose I want to generate all possible n size subsets, n length subsets, which is same as number of subsequences of array of size n. Fine. So you create an n. So suppose you have an n bit number, and you iterate that number from 0 to 2 power n. So let's see for n equal to 3 how we are going to solve. So for n equal to 3, we will iterate from 0, then we'll go to 1, then go to 2, then go to 3. So for each n, iterate from 0 to 2 power n minus 1. And for each number, I will generate is for each such number, I will generate a unique subset. So I know that there are 2 power n subsets, total 2 power n subsets. And suppose for each number 0, 1, 2, 3 till 2 power n minus 1, if each number I can generate a unique subset, then overall I will be able to generate all the 2 power n subsets. So for example, in n equal to 3, I will iterate over 0, 1, 2, and 3. For number 0, let's consider it in 3 bits. So it means none of the numbers is selected. So this corresponds to empty set, empty subsequence. So suppose this is 0, 0, 1. So you can see that its 0th bit is set. 0th bit is 1. So bits are always, you go from like least significant to highest significant. So you go from right to left. So this one would be 0th bit, this would be first bit, this will be second bit. If 0th bit is 1, it means A0 is selected. It means that first element is part of subsequence. Is part of subsequence. Fine. So this in my case will become correspond to 1. So 0, 1, then it becomes 2. So in 2, first bit is set. So it means that second element will be the part of subsequence. Which means my subsequence will become just 2. Then 0, 1, 2, 3. How do I write 3? 0, 1, 1. So here 0th bit is 1, 0th and first bit is 1. So these both will be part of subsequence. So what is number at 0, 1 and 2? So 1 and 2 will be part of subsequence. So my subsequence for n equal to 2 will become empty subset, then 1, and then 2, and then 1, comma 2. So let's try for n equal to 4. So I'll go from 0 till 15, which is 2 power 4 minus 1. And for each number, I can find out a unique subsequence. And how do I find out a unique subsequence? I just represent that number in binary, and whichever bit is 1, I take the corresponding element. So let's try implementing that. So I will go from, let's call this number mask. So this number is called mask. I'm just giving this number. So this is 2 power n. And let's say int n is equal to 2. Fine. Mask plus plus. So what I'm trying to do is for this number, find all its bits. So let's say this number is n. So while n is greater than 0, would be n% 2. If bit is, so let's just print its bits. We will just print its bits forever. Right? Vector int bits. Bits dot pushback bit. Divide by 2, and let's say reverse. So and just print. So for number 2, this n, sorry, let's keep this to be. So you can see I am trying to write binary representation of these numbers. So suppose n is equal to 4. So I will go from 0 to 2 power 4. And for each number, I will write its binary representation. So this one will give for each, so this line will print for each number from 0 to 2 power n, what is its binary representation? This will print binary representation of each number mask. So let's see. So you can see binary representation of 14 is 111, 0. For 11 is 1011. Of 7 is 111. Of 3 is 1, 2 is 1, 0. So we have just written binary representation. Fine. So now you can see that no two numbers have same binary representation. And using corresponding binary representation, these bits, I can find a subset. So suppose this is my binary representation 1010. So I will not choose 0th element. I will choose first element, and then I want to choose second. I will choose the third element. In this case, I will choose first element, 0th element, first element. Second, I won't choose. Third, I will choose. So I will iterate over these bits. Let's say I goes from 0 to I less than bits of size I plus 1. If bits of I is equal to 1, for this vector in subsequence, then my what will I pass in my subsequence? A of I. And let's just print mask comma bits comma subsequence. Let's see. It's not print. And let's keep vector int A here. Let's keep n equal to 3 and see what happens. So what should happen? I will print the corresponding number mask. I will print it binary representation. And for that given binary representation, I will print what subsequence does the binary representation correspond to. So let's see. So for number 0, the binary representation is empty, and this one doesn't correspond to anything. So for number 1, binary representation is just 1, and this will correspond to selecting the first element. Then In this case, number 2, the binary representation is 1, 0. Sorry, we should go from reverse. So let's not reverse at this point and just do this operation. Because binary, okay, let's reverse. We will go over the binary representation from the end to this thing. We will go from right to left. So bits dot size minus 1, I greater than equal to 0. Or let's say I goes from 0 to I less than bits dot size, and my idx will become bits dot size minus I minus 1. So this is, so what is happening? I'm going from, this is going from right to left. Right to left. Because for I is equal to 0, this index is bits dot size minus 1. For I is equal to 1, it's bits dot size minus 2, minus 3, and so on and so forth. Fine. So let's try this. So in this case, so you can see that binary representation of each numbers is fine. The number 4 has 1, 0, 0. Number 6 has 1, 1, 1, 1, 1, 0. 7 has 1, 1, 1. Now you can see that for number 0, the binary representation doesn't have anything, or you can say it has 0. So it will not have, there will be empty subsequence corresponding to it. For 1, you can see that first 0th element is set, so it will have only 1. For 2, you can see that 0th element is 0, but only first element, first bit is 1. So you will choose the first element, like the second element. So you'll choose 2. If this is 1, 1, you will choose both 1 and 2. If this is 0, 0, 1, you will choose the third element. If this is 1, 0, 1, you will choose first element and you will also choose the third element. In this case, you will choose second and third element. In this case, you will choose first, second, and third element. First, second, and third element. Do you see how binary representation of a given number corresponds to a subset? So suppose, let's say n equal to 5. And I ask you, my binary representation is 1, 0, 0, 1, 0. Suppose this is my number. So what subsequence will it correspond to? Can you tell me? For n equal to 5. This is my number. What subsequence will it correspond to? Can you tell me that? For n equal to 5, then bitwise representation is 1, 0, 1, 0. So this number will correspond to which subset? This will correspond to the first and third. So suppose your array is 1, 2, 3. Suppose your n is 1, 2, 3, 4, 5. What should be here? Suppose your array is this. What subsequence will it correspond to? I'll choose the first index and I'll choose the fourth index. So what are they? So I'll choose first index. So indexing is 0 based, remember? So I'll choose index at 1. I'll choose element at index 1 and index what? At index 4. So what is element at index 1? What is element at index 1? It is 2. What is element at index 4? It is 5. So can you tell me what will be the answer for 1, 0, 1, 0, 1? This one. Can everyone tell me answer for this case? What subsequence will it correspond to? One zero one zero one. It will correspond to 1, 3, and 5. Yes. So you can see that for every number from 0 to 2 power n minus 1, which is 2 power 5 is 32 minus 1, 0 to 31. Each number will correspond to a single subset. And you can find that subset in this way. Suppose someone asks you to print all subsets. What you will do, you apply the same code and you print the subsequence. Just do this thing. So for each, these are all the subsets for n equal to 3. Suppose you want n is equal to 4. You can see that for n equal to 4, these are all your subsets. Empty 1, 2, 1, 3, 4, 1, 2, 3, 1, 3, 4, 3, 4. So this way you can also generate all possible subsets. Did you get this idea? I'll just go ahead and simplify this code a bit. But at least you get the idea ki how for each number in binary representation, how can I find the corresponding subset? Is that idea clear? Should I repeat the idea or should we go proceed? Like at least if this idea should be clear to everyone. For a given number mask and its binary representation, can you find the corresponding subsequence? Is this clear to everyone? Write in binary, go from right to left, and with corresponding bits, if the bit is 1, then you take that corresponding to that bit's index and you will be done. So now you can write this whole code in slightly succinct manner by using bitwise operations. So let's do that. So I'll iterate over this. Now what you just do, you iterate over each position from 0 to n. And if you just check, so this is iterating over the bits from right to left, bits of mask. Now I have to check whether ith bit of mask is 1 or not. So how do I check whether ith bit of a given number is 1? So how do I check of a given number mask whether the ith bit is 1? So what I can do is I take mask and I take the number 2 power I. So 1 followed by I zeros. So I take that number and so basically, so suppose your mask is 1 0 1 0. Fine, and let's say 1 0 1 0 1 and I is equal to 2. So you want to check whether the second bit is 1. So what do? You create another number equal to 2 power I. So 2 power I is 4. So you take another number where the ith bit is set. So the second bit is 1, remaining bits are 0. So you take another number. So this number corresponds to 2 power I, which is 4. This number corresponds to 4. You take this number. Both of these two numbers you take bitwise AND. Do you know what is bitwise AND? Bitwise AND operation. So what is AND of 1, 1 and 1? What is AND of 1 and 1? What AND of 1 and 1 is 0. What is AND of 0 and 1? Fine. This would be 0. What is AND of 1 and 0? What is AND of 0 and 0? So you can clearly see that AND will be 1 if both the bits are 1. So suppose this number is mask. This number is 2 power I. Now I ask you what is AND of mask and 2 power I? What is that? What is AND of these two numbers? 1 0 1 0 1 and 1 0 0. What will be the leftmost bit? The leftmost bit will be 0 because 1 and 0 is 0. What will be the second leftmost? Second leftmost would be 0. What will be the third one? third from the right, third from the right bit would be 0 again, or will it be 0 or will it be 1? So we are trying to find 1 and 1. So what is 1 and 1? 1. What will be the fourth bit from the right? Fourth bit from the right. So this 0 and corresponding 0 here. So that will be 0 and another would be 0. So what is this number? 0, 0, 1, 0. This number is again 2 power I. Do you see that? So if this number's ith bit is 1, then this numbers end with this 2 power I. This end would itself be 2 power I. Otherwise, what will be the end? So suppose I want to check for this mask whether the third bit is 1 or not. So 10101 is my mask. Now I is equal to 3. What will be 2 power I? How many zeros after 1? For I equal to 3 in 2 power I, how many zeros will be after 1? So in 2 power 3, how many zeros are there in binary representation? How many zeros? In 2 power 2, how many zeros? 2 zeros. So in 2 power 3, how many zeros? 3 zeros. This number is 2 power 3. What is end of these two numbers? Mask and 2 power 3. What is end of these two numbers? End of this number and this number. Can anyone tell me what is end of this number and this number? First bit would be 100, second bit would be 000, 100, 010, 100. The end would be 0. Is this clear to everyone? So if the ith bit of mask is 1, then mask and 2 power I, then value of this would be 2 power I. Otherwise, the value of mask and 2 power I would be 0. Is this clear to everyone? This no. Is this not clear to everyone? If the ith bit of this number is 1, then if I take this number's end with 1 power I, 2 power I, this would become 2 power I itself. Otherwise, its end will become 0. Is this statement clear to everyone? Anyone wants to? This is like very important statement. If you have any doubts, let me know. I will be happy to explain it again. Does everyone get this part? Why this end will be 2 power I itself and why this end would be 0 if the corresponding bit is 0. Otherwise, if the ith bit of mask is 0, then the value. Is this clear to everyone? No one is saying, everyone is silent. Should I repeat or what? Anyone? Clear? So now how do I check whether this element I should be taken in my subsequence or not? So what I will do, I will take mask and 2 power I. I will take these two end, and this, if this end is positive, then I would say this number is part of my subsequence. So vector it subsequence. So I will do subsequence dot pushback AI. And here I will print mask comma subsequence. Is this line clear? If mask So if the corresponding bit is 0, then the mask becomes 0. If the mask is positive, it means the corresponding bit is 1. So I should choose AI. Is this clear to everyone? So this way, you can just iterate. So let's comment out this code. And let's even like comment on this. So now my code for generating all possible subsequences, I iterate over mask, then I iterate over all the bits, and I check whether the corresponding bit is 1. If the corresponding bit is 1, I will push the corresponding ith element in the subsequence. So this will generate my all possible subsequences. So now you can see for n equal to 4, it is generating all possible subsequences 1, 2, 3, 4, 2, 3, 4, 1, 3, 4, 1, 2, 4, 2, 3, so on and so forth. So clear to everyone how this method is working, how I am checking the ith bit. So finally at the end your code just becomes like literally 1, 2, 3, 4, 5, 6, 7 lines code total. What is time complexity of this method? Time complexity. The outer loop will run 2 power n times and the inner loop will run n times. So this becomes 2 power n times n. Is this clear to everyone? Why its time complexity is 2 power n times n? This loop runs 2 power n and this loop runs n times. So now if someone asks you how to generate all possible subsets in 2 power n times n time, you can just write your code quickly as this thing. Don't even need recursion as well. Fine. Is this clear? Should we proceed further? So let's go and write a code for permutations basically. So this time I want to print all possible permutations. Okay. So let's write a code to print all possible permutations. So for n, for number n, can you tell how many permutations are there? There for given n, given number n is n factorial. Fine. So what will be permutations of n equal to 3? For n equal to 3, the permutations would be 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 2, 3, 2, 1. Did I miss anything? And these are total 6 permutations. What is 3 factorial? Is 3 into 2 times 1, which is 6. So you can see that for n, there are n factorial permutations. And these are 6 permutations. Cool. So now using recursion, I want to find all of these 3 factorial permutations. So how can I solve this problem? So I will just be given n. I have to print all these arrays. So how do I solve this question? So there is one what is the simplest way? Let's try that. So in my recursion, suppose I maintain key. What set of elements have I taken? So suppose if I have taken 1, then I take 2. Here I take 1, 3, 2, 1, 2, 3, 3, 1, and so on and so forth. So I can see what set of elements have I taken. And I can try extending that basically. So let me just try writing one code and see vector int form position, let's say, or maybe just that permutation. And let's pass the int element n, and let's say I'll just write some code. I'm not sure whether it's correct or not. Let's just experiment and see how to write some code for this. Otherwise, I iterate from all element from 1 to n. And if this element does not exist in permutation, I will try appending in the permutation. So what do I do? Find permutation dot, or maybe like let's not define boolean exists equal to true, exists equal to false, for int elem in perm. If this elem is equal to I, then exists equal to true and break. If it does not exist, then I can append this number. So let's call recurrent new form is equal to form, and new form dot push back this element I, and do recursion from n with this new form. This is at least some code. I'm not sure whether it's correct or not, but it is some code. The idea is you maintain some set of permutations you have generated till now, and you add an element if that element does not exist in that. So this could, let's try with this code. N is n, and vector int form is empty. So let's say vector int empty. Let's say n. So let's try this and see what happens. There seems some compilation error. Yes, so that is fine. So this, for n equal to 3, this has printed correct. Let's try for n equal to 4. And let's see. For n equal to 4, it has for 1, 2, 3, 4, 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, 4, 3, 2, 2, 1, 3, 4. So let's just print their count also so that we can get a better idea. Total is equal to 0. And here I will do total plus plus. And I will also print the count. So n is equal to 4, 4 factorial is 24. So this seems to work fine. Like you can see for n equal to 2, n equal to 1. For n equal to 1, it seems like permutation is 1, total is 1. For n is equal to 2, this is 1, 2, 2, 1, 2. For n is equal to 3, you can see 3 factorial. So what is the idea of this first program? So first program, what we were maintaining, we were maintaining some permutation till now, And I will then append something in the permutation, and I will append some number which does not exist in the permutation, and I will keep on doing this. So let's try with n equal to 10 and see how much time does it take. I think it's taking a lot of time. How much is 10 factorial? 3 into 10 power 6. Seems to take a lot of time. So let's remove this printing and just print this total. So it's taking a lot of time. Usually like 10 factorials should be running within the time. So this code is pretty slow. It has taken like 16 seconds. You can make it faster. So for example, here we are doing order n for checking whether this element exists or not. We can maybe do this step faster and stuff. Anyway, the basic idea is of this recursion is you maintain some permutation till now, and you find what is the next element that I can insert. So the vector form denotes the current prefix of the final permutation that I want to generate. Fine. And I go and try each possible number to append to the vector form. So the idea is you maintain some prefix of your permutation. So you maintain some initial part of your permutation, and you keep appending to it the number that is not in the permutation, and you keep trying this, and eventually you will be having a permutation. So does everyone understand this part key? How this simplest code is working? We will figure out other good ways to work also, but at least is everyone clear how I am generating this permutation? So one optimization that you could do, so let's do perm.pushback, let's say I, and instead of passing new perm, let's say just say pass permutation itself. Do you think this will work fine, or will there be some problem? Because I am going in the loop here, so if I have inserted I, in the next iteration, this I will be counted again. So I should do perm.popback. I should remove this element also. So if I run this one, this may run a bit fast. I'm not sure how fast. Maybe a little bit faster. Yeah, a little bit faster. From 16 seconds to it became 11 seconds. Fine. Did everyone get this part? Why this is required? Because in the next iteration, if you don't do this thing, in the next iteration you will have I appended in this permutation itself. So that will cause you a problem. You can also make this function slightly bit fast. You can create, let's say, an array of size n of exists, and you can go over this your permutation, and you can say, let's say, n plus 1. You say exists of lm is true, And instead of doing this, you just say if exists not exists of I. So here, instead of checking in the loop which element exists, you just store them in an array that these are the set of elements there. And now it will be slightly faster than the original code. It doesn't exist, you put it into this. It's not much faster, it's somehow same stuff. Anyway, did at least get this idea how to write a very basic permutation. We will go over strategies to how to make it better. Is everyone clear with this code key, what it is doing? Any doubts? Anyone wants to ask anything? Why this code works? This one is like much simpler to argue that this is correct. Because you know that this is your current permutation, you are only appending elements which aren't like, which don't exist in that permutation, and you keep doing this for n iterations. So you are sure that this will result in a proper program. So there is another like famous method that many people use, which uses like swapping. So suppose this is 1, 2, 3, 4, 5, your initial permutation. So from using this permutation, you can generate all possible permutations just by swapping the elements. So suppose you keep 1, 2, 3, 4, 5 same, 1, 2, 3, 4 same. You cannot do anything with 5. Suppose you keep 1, 2, 3 same, then you can permute 5 and 4. So you get 5, 4. Similarly, you keep 1, 2, 3, 1, 2 same, and you permute 3, 4, 5. So permutation of 3, 4, 5 would be 4, 3, 5, 3, 5, 4, 5, 4, 3. So you keep your prefix same and you permute your remaining part. So essentially, like, suppose you keep 1, 2 same plus generate all permutations of, let's say, then permute this 3, 4, 5. So this will generate 1, 2, 3, 4, 5. This will generate 1, 2, 3, 5, 4. This will generate 1, 2, 4, 3, 5, and like many more. 4, 5, 3 also. And then 5, 3, 4 and 5. Here 5, 3, 4 and 5, 4, 3. So you can write this in multiple possible ways. Key. It depends key. There are like multiple ways which you can do the same permutation. So let's try another way. So void, let's close this recursion. And I'll just try something and let's see if it works. Int index and let's say vector int permutation. Can I do in place is the idea. Let's see if index is equal to n print permutation. This let's N is, I think, permutation size. So here what we are trying to do is key message. Okay. So let's see key. So suppose you keep elements from 0 to index same, and you do permutation of the remaining and permute the remaining. So what you could do, you could, let's say, index plus 1, keep, let's say, permutation same. Or what is the other way? So essentially what I'm trying is key. So in this case, if you see this thing, you keep some prefix constant and you permute the remaining part. And so essentially I kept 1 to constant and you permuted the remaining part. Then what I will be doing, I will keep 1 constant and you permute the remaining part. Or essentially you could even think it of, you take 1, 2, 3, 4, 5, and initially it is 1, 2, 3, 4, 5, and then you, let's say, swap 1 and 2. And so suppose you fix 1 and you permute everything. So 1 comma, all the permutations of 2, 3, 4, 5. 1 comma 1 plus permutations of 2, 3, 4, 5. And then you swap 1 comma 2. So it will become 2, 1, 3, 4, 5. So then you do 2 plus all permutations of 1, 3, 4, 5. Then you essentially swap, then you swap 3 at index 1. So then your number becomes 3, 1, 2, 4, 5, and generate all permutations. So what you do is you bring all the numbers from some position to here and you generate all the permutations. So essentially what you did, you first position you keep 1, first position you keep 2, first position you keep 3, then first position you keep 4, first position you keep 5, and then you generate permutations of the remaining element. So this would be, 3 plus all permutations of 1, 2, 4, 5. Similarly 4 and 5. Similarly this would be 4 and this would be 3. This would be 5, this would be 4, this would be 5, this would be, I think, 1, 2, 3, 4, 3, 4. Fine. So how to implement this thing is the status. So this is my permutation array, and I call recursion to generate all permutations, and then I swap this number with all the numbers. So what I'm doing, I'm going over all I from, let's say, index plus 1 to I less than permutation dot size, swapping ith element with index. So even like keep index, swap permutation of I comma permutation of index, or swap index with ith element, and then you generate then you recurse with index being next index, and your permutation will remain same as permutation. And let's say after doing this, you do this reverse of swap, because this swap should not be reflected in the next operation. So this code, let's say I try. I'm not sure whether this will work, but let's try this code. They'll try explaining what is happening. And permutation should be recurrent permutation. So for permutation dot instead of passing recurrent empty, let's pass permutation. And let's print this thing and see how does it do. It's total declared, yes. So let's see. I'm not sure whether this is correct or not, but we will be able to fix it up and see where there is a problem. So n is equal to, let's keep n is equal to 3 first and try. So for n is equal to 3, it just printed 1, 2, 3 and did nothing. Okay, so there must be some problem then. Because you see, it just printed n equal to 3, 1, 2, 3, and it just got exited. So what is happening? The permutation has 3 elements and you call recursion. But okay, your index was 0. So let's keep your index to be 0. Otherwise, it will just going at the end. So now what is it doing? So you see, for 3 it seems to print fine. Let's try understanding what is happening in this case. So initially my permutation is 1, 2, 3, 4, 5, or let's say just keep 1, 2, 3. So let's print permutation and index here. Debug. Permutation. So you can see initially index was 0, permutation was 1, 2, 3. Fine. Then I tried swapping 0 with 0. So nothing will happen. In the next case, permutation would itself be 1, 2, 3. And I will become 1, the permutation is 1, 2, 3. Now what I did is try swapping with 1 itself and it remains same 1, 2, 3, 1, 2, 3. And in the end it printed 1, 2, 3. Otherwise, it will take 1, 2, 3 and it will swap the corresponding element. So it swapped 2, 3 and it tried again. So essentially what is happening, he tries swapping each element a of each element I greater than equal to index with a of index. And then it will change your permutation and will generate all possible permutations. So if you did not understand this, see this part. So suppose your permutation was 1, 2, 3, 4. So in the initial position, you can keep any of 1, 2, 3, 4, and 5. So you bring one of them at the initial position. You can bring 1, 2, 3, and 4, and 5. So that you can do by swapping each element with first element 1. So if this was 1, 2, 3, 4, 5, in this iteration, what will happen? In first iteration, this will become 1, 2, 3, 4, 5 itself. In the second iteration, 1 and 2 will be swapped. This will become 2, 1, 3, 4, 5. In the next iteration, 1 and 3 will be swapped. In the next iteration, 1 and 4 will be swapped. In the next iteration, 1 and 5 will be swapped. So let's not go into recursion and just see what is happening. What is this swap doing? So debug permutation. Let's just do the single iteration. What is happening in the first iteration? So my array was 1, 2, 3. So I keep 1 at place of 1. Then I swap 2 and 1. Then I swap 3 and 1. Do you see that? Sorry, here you should do the reverse also. Otherwise, it will. So you can see that 1, 2, 3. Here I swap 2 and 1. Here I swap 3 and 1. 2 remains as it is. So if your n is 5, you can see what I'm doing. So initially I keep 1 at the beginning, then 2 at the beginning, then 3, then 4, then 5. So essentially, find all permutations of the remaining part, keep 1 at the beginning. Find all permutations of 1, 3, 4, 5, keep 2 at the beginning. All permutations of 1, 2, and 4, 5, keep 3 at the beginning. So essentially this algorithm, what it is saying, you decide the first position. What number will be at the first position. You decide that and you do the permutation of the other numbers. So it's essentially fix the first element. So the first element could be one of the n elements. So you fix one of them and try and recursively try finding permutation of the other elements. Recursively try finding permutations of the remaining n minus 1 elements. You can even, instead of writing this algorithm in this way, let's write it in very simple way. Recursion. So let's omit this. And let's call it int index, comma vector int permutation. Fine. Then if index is this, then you print. Otherwise, what do? Otherwise, you fix the first element basically. So you fix the indexed element and you try finding permutation of the remaining elements. So even let's do this thing, vector int. It will convert to like the previous program, this program. Maybe let's try this. Int index, comma vector int permutation. So this, then I have to decide the first element. So let's call it vector int new permutation. And then I will go from, essentially it becomes very same as the previous program. It becomes exactly this program if I implement this again. But essentially the idea is, do you get the swapping idea? What I'm doing by swapping? So by swapping, what I'm doing, I am bringing I'm deciding what element should be at first position. So I'm going through all the n minus 1 and trying all of them to bring to first and finding permutation of the all. So essentially fix the first element and recursively try finding a permutation of the remaining elements. And you can implement it using this. And this swap, why do I need again? Because if I don't do this swap operation again, for the next iteration, this will become a problem. So if there was no for loop, I could have left this function as it is. Otherwise, I cannot leave this function. Is everyone clear what is happening? Anyone wants me to explain this? This is like very simple but very important concept. Like why this swapping part works. No one? Anyone wants to say anything? Nothing in direct messages. Does anyone get like what this recursion is doing and why this is correct? Do you get why I am not doing this? What will be the issue with this? Which sort of permutations will it miss? So for both the concepts, like time complexity is more or less the same. It is n factorial times maybe this iteration may take another order n. But overall, like you could say the time complexity is more or less the same. This one is slightly faster than previous because we are not using slightly complex operations. For example, we are just passing the single permutation array here and there. And also we're not doing existence checking and all those sort of stuff. So this one is like bit faster, but complexity wise there is no difference really. So if I try running for n equal to 10, let's try running this for n equal to 10 and see how quickly this performs. It may be like quite faster than previous one. We will see. Previous one was taking like some 11-12 seconds. And this one seems to have taken much less time. Yeah, this one is taking only 4 seconds. But overall time complexity wise, both are like n factorials. There is not much difference actually. It's just like here you are not doing much complicated operations. So this one is much faster. Do you get the idea? Yeah, that is fixed now, I is equal to index. Which one you were saying we need to fix? Pranav? This index plus one, I had changed it to index. You can see that 10 factorial is 362880, I think. 362880. Is that fine? Yes, earlier it was index plus one, but I made it to index before running. So this is fine. So everyone clear with this permutations idea? Will time decrease if you pass reference? So let's try. Whenever you are passing reference, you have to be slightly less careful and check your logic properly as well. Key. So suppose you pass reference here and let's see what is happening. Then you need to be slightly careful and maybe run your program and be sure what you are doing. So let's just first be sure that with reference this program is correct or not. I'm not sure whether it's correct, but let's try running for n equal to 3. So with reference, this seems to work fine. And so essentially you think why keeping a reference, it does not change much in this case. So whenever you want to make something reference, make sure you understand key by making it reference, your program does not get messed up. Because, so suppose this is at some particular state, index comma permutation, and you go to some state, you need to make sure that when you come back to this state, this permutation hasn't changed. This is same as the previous state. So suppose this is your recursion tree, and you are at this state, and you go to the left, again, and again and again. This way you have done these operations, and suppose finally you came back to this position again. At this point of time, you should make sure that whatever state you were, that hasn't changed by passing references. If you can make sure of that, then you can use references. So in this case, we can clearly see that that is true. Our program works exactly the same with references. So this one will be significantly faster than the previous one for n equal to 10. So this one is like much faster, way faster than that. This one is taking just 0.25 seconds. In fact, this is order n times faster. So it did, because we are copying this function otherwise. So this one run in like 0.25 seconds, other one was running in 4 seconds. So for 16 times faster. Clear? But always make sure when you want to make something reference, run the code at least once and see in the recursion key, is it fine to keep that as a reference? Here we are only swapping elements, and yes, so essentially like when you want to see when the reference strategy will work, the idea was same. Suppose you started from some particular state in recursion and you went to lot of states, and whenever you come back to this state again, does your code ensure that you will be in the same state before you went into the recursion? So if you can always make sure of that, then you can use references. Otherwise, so suppose you modify permutation array here somewhere, then you are kind of, then you come back to the original recursion state, your permutation would have been changed. So keeping permutation as a reference won't work there. So you can only keep as a reference when you are sure that whenever you come back from the recursion to this state again, you will be in this exactly same position. That your permutation array will not be changed. If you can ensure that, you can use this thing. Otherwise, you cannot use that. Is this clear? So similarly, if someone asks you to, let's say, print all strings with some property. So let's say someone asks you this question. Print all strings which have a comma b comma c. All strings of with characters at a, b, and c. A, b, let's say this thing. So you can see that there will be total how many of length n, how many strings would be there? 3 power n strings of length n. So suppose someone is asking you print all strings of length less than equal to 10, let's say. So how many strings would be there? Can anyone tell me? That would be 3 power 1 plus 3 power 2 plus 3 power 3 dot dot plus 3 power 10. Can you do this problem with recursion? Print all strings of length less than 10 with characters at ABC. So for example, AB's, these are all good strings. A, C, B, A, B, 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 A, B, A, B, B, C, B. These are all good strings. Does anyone want to explain how to do this program? Anyone who want to explain this code? Okay, how to solve this problem? Any takers? So how do you solve this program? Can you write recursion yourself and share your recursion here? Just write your basic recursion part. Its program will be very simple, like very small. So just write its recursion on your text editor and copy paste your recursion here. So this recursion, what would you pass? What will be the parameters? So in that, and what will you print? And then what will be your recursion? Can you do that? So what's the idea? What will you pass in your recursion? You will pass a string, which will denote key. What is the string till now? And I think that's all you need. You don't need anything else in your recursion. Just pass a string and you print that string, and if its length is less than or equal to 10, you print it and you go to recursion again. Anyone wants to say a code? Wants to say anything? Meanwhile, I will find some backtracking problem to solve. You guys like do this thing. You guys write recursion for this program. So this code is same as what we did earlier. So let's try passing that up. Nums. So here we pass and here pass it. You guys work on that, writing recursion for this program. Write in the chat how will you find recursion for this. This one is pretty simple recursion. Does anyone was able to run that? Was able to write code for this program? Question. Try writing recursion. So you can try solving this question on LeetCode. This is like trivial example. Like whatever I told you can easily use the same and solve this. Yeah, this one is nice question. Unique collection numbers that will contain duplicates within all possible unique permutations in any order. So this time it asks you for unique permutations. Anyone wants to explain this code? Then we will go to this unique permit, this question. We will try solving this question. Before, let's try solving this question. Anyone wants to explain this? Any takers? Anyone? Are you guys even listening? Hello? Is everyone clear with this question at least, Keith? What I'm trying to say. Print all strings with this character ABC. Is everyone tired? I'm not able to listen. Okay, print index, then. So instead of taking vector of char, you can take string as well. So use string instead of vector of char. Strings are much nicer. You can just do append operations on strings. Okay, good. Someone attempted. That's pretty good. So let me just explain how you can do. Just forget this. So you'll just do recursion and you maintain your string s, and if the size is greater than 10, you just return, otherwise you print the string, and then you try character from A to C, character plus plus, recursion of, let's say, s plus ch, and this will do. So you call recursion of empty string. To print all strings. So let's try with slightly lesser strings, maybe just 3, and see how many it prints. So you can see it prints this way. Is this clear? Is this code clear to everyone why this is solving the question? So suppose someone says print all strings, but make sure that no three conjugative characters should be equal. 3 conjugative characters should be equal. So how do we apply this condition in the recursion? So for example, AAA is not good because A appears conjugatively thrice. AAB is good. AAB is good. ABB is good as well. But no 3 conjugative characters should be good. Can you, how will you modify this recursion? By adding this condition separately. Can you do that? So can anyone say its code with me or want to explain how to apply this condition? Anyone wants to come on call and explain? I'm not able to listen to anyone, so maybe my camera is not working properly. Is anyone speaking?
Hi, uh,
Hello, who is there?
Mohammed Afsan. Is it audible?
Hey, hi Afsan. Yeah, you are audible. So what changes will you make here?
In for loop, we are starting every time from ch is equal to a.
Yes.
We can pass s plus sh comma ch plus plus maybe
Okay.
every time. Maybe it will work. I don't know.
Okay. So one thing is key before appending here, You want to make sure that the last two characters of S are not equal to CH, because then this string will start containing three occurrences of CH. So at this point, you want to make sure that string S does not end with CH. So if the string is, let's say, ACC and your current CH is C, then you should not go into the recursion, isn't it?
Yes, yes.
So how do you check key, what are the last two elements of the string, whether they are equal to this or not?
We have S, then S of n S dot length.
So let's say
Yeah.
n equal to this. So
If S of n minus
first of all, n side should be at least 2, otherwise
at least
counter
greater than
doesn't matter.
and S of
N
n
minus
minus
1
is equal to CH and S of n minus 2 is equal to CH,
equal to
then we
CH.
don't have to.
Then in this case, don't go into recursion.
Yes.
So in, let's say OK equal to true. So I say OK equal to false. And if it is OK, then only I will go into the recursion.
Otherwise, we will not go inside this inside this recursion. Yeah.
So is this code fine?
I think it will work.
Yes. And there's another way of doing the same thing.
How?
And that way is, instead of doing this, in your recursion, you pass what were the count of last equal characters. Fine. So here count of last equal characters. Fine. So if size of is greater than 3 or count of last equal is greater than equal to 3, then you return. So now what will you do? And you also maintain the last character. Last character. Okay. So what is like new count of last equal? So if character CH is equal to the last character, you will do recursion S plus CH. Count of last equal would become 1 and last character will remain same. Otherwise, you do the recursion with S plus CH. What is count of last equal?
Then we will do 0.
1. The element itself.
Starting from 1, yeah.
And this will be 1. So you can do this recursion. And here you can pass, initially you pass count equal to 0. And last character is, let's say, empty. It's not taking, maybe like some character, I don't care much, maybe some star. And this program you can try running. So this one does not have any 3 conjugative, does not have AAA, you can say.
3 is all 3 consecutives are not present.
3 conjugative. So in recursion, you can pass these parameters and you can modify in the recursion, or you can, like, if you can somehow test your thing, you can do that itself. So both
we are counting every time the last characters inside the original string.
yes, last equal characters inside the original string.
Okay.
So suppose someone asks you that string abracadabra should not be there. So let's say string ABCCBB, this string should not be there. So here you will check if s.size is greater than 3 or s is equal to this, you just return, you don't do anything. So you print only when the string is in the good state. And at this point, you are sure that whatever string you have, that satisfies the right properties. So now let's come to this question, try solving this question. So here we want to print all the permutations, but we should not print duplicate permutations more than once. So how do we solve this question? So one way to solve this question is you kind of find all the permutations, then you remove the duplicates and just print the non-duplicates ones. That is one strategy. Fine. What is the other strategy? So the one strategy is you find all permutations. Find all permutations, including duplicates. Including duplicates. Then remove the duplicates. So you can remove duplicates by putting the permutations inside a string, inside a set of vector its, and that set will do the duplication part. Should we try implementing this? You guys want to implement this? So can you implement this code on your own? Just the first part, find all permutations including duplicates. Can you do parallelly with me? Maybe try solving this problem, permutations -2. Try with me itself. Write code for finding all permutations including duplicates. So the original code that we written down, that was recursion, and we had some few things. Vector int, in this case, let's say nums itself. And we had int index. Then you do some iteration, and finally you print all the permutations. So let's say vector of vector int, address of, let's say, result, address of, let's say, forms all permutations. So how do I do this? Index is equal to nums.size. What do I do? Can I do this? Forms.pushback form. Otherwise what do I do? For from index, say I less than nums.size I plus swap nums of I with nums of index. Call recursion with index nums being same, forms being same, and then do this iteration again. Okay, and let's call this with recursion 0 nums. Let's call it forms. Vector forms. Let's print all combinations. So vector in form. Yeah, this way it should be able to print everything. And let's say I'm just returning including duplicates. So this one for 112 it's wrong answer. Let's try on the test case 1, 2, 3 and see what is the answer. So 1, 2, 3 our permutations should be. So STD out is 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1. And your forms was 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1. So this one is without duplicates. Sorry, this one is with duplicates. We have to make it without duplicates. So we have to remove duplicates. So how do we remove duplicates?
While swapping, if we find two equal values, then we don't have to swap it. We'll move on with the next one like that. So we'll just have only whenever we swap in that function, if we find two equal values, then we don't have to swap it.
So, okay, so what you're saying that we do this thing, if nums of I is equal to nums of index, we do continue.
I mean, once we need to execute it, but somehow somewhat like this only.
Okay, we need to execute it once. So you're saying I not equal to index, and if this is equal, then you continue.
Yeah, I guess somewhat, yeah.
So let's try this one, 112, and run and see what happens. This one saying triple equal to error, so we fix that error. This one seems to pass. Do you think there is some problem here?
I guess I'm not really sure about it, but just the first guess.
Okay. So let's try 121. Let's try on this thing and see whether it works. 121. 121, it says 121, 112, 21. Seems to be fine. Expected and the remaining is same. Okay, so first thing, do I need to sort this nums array? That's my question. Do you require this array to be sorted or not? Okay, let's submit this and see what happens. So in this case, we have faced some issues. So you can see we got a wrong answer. The 2211, it was expected only, like we printed 2211 how many times? Printed some number at least more than once. What was that? Printed 1212, 1212. So there's some issue. We are printing something more than once. Let's do one thing. Let me just do sorting at the beginning and see whether it's able to pass or not. And then we'll see whether it's required or not. Okay. Let's try. This also on this case is not working good. Where is it working completely? It was saying 1212. 1212 is getting printed more than this. So there is some error. What is that? Let's take here 2211. Let's try debugging key. What is happening? Why we are not getting correct answer? Yes, this is saying wrong answer because you are printing too many stuff. So how to avoid that? Any areas? Apparently, nothing much happened due to sorting. Maybe we can keep sorting. So how do we deal with this? Where do you think there can be some problem? So in case of 2211, we are printing this 1212 multiple times. So suppose we started with 1122, and for this one we did not swap. For this one we did swap. So our array became 1212.
We can maintain Boolean hazmat or set if it is present inside it. We don't push the elements in it.
Okay. We can do that.
Inside the if condition of index is equal to nums dot size, we will also check here if if the nums is present inside the has map or not. If it is present, we will not push it. We will just return null and continue another recursion.
Okay.
Because anyway we are inserting all the elements inside it, and at this condition we will check that element is already present. We won't insert it.
Yes, yes, yes. So do you see like why we are having duplicates despite like writing a condition key if two numbers are equal then you don't swap, otherwise you swap. So you are not swapping equal elements, but you are still facing problems.
It is only not swapping that elements, otherwise it is inserting it. In, we have written if I not equal to index and nums I is equal to nums index, then in this condition we are not swapping, but that element is already given there.
That is,
I don't think I'm saying right, but the map will work. I think unordered map, we will take unordered map, and in that condition it will work.
Actually, the problem is like there are too many duplicates, right? Like 1122. At some point, it actually seems like it obeyed this rule. Okay, I mean the if condition, but at next stage, next index plus I, it again swapped some duplicate element, but it didn't. I mean, took care of it. Like, we couldn't take care of it. So when we see it, like it will be in some other position. The I index I will be in some other position. I mean, we incremented some other place and swap took somewhere else, but the repetition might have happened in some other first or second. We didn't notice it. So like that, it keep doing it like that. I guess.
Actually, in the output where we got wrong answer, we can see that first is a 1122 at the same output steady out 1122, and the second 1212. I am considering 1212 at the first position where 2 is there, and we are considering here 2 is second position is not equal to third position, and at the
yes.
same time we also considering 2 is not equal to index. Then we are coming out of if condition, it means swapping, and 2 and 1 swiping, we got previous value again. That is the case.
Yes, we will get previous value.
It means a lot of repeating numbers are there. That is why we are getting this.
So how do we like ensure in this code that this doesn't happen? So let's think of it in this way. My number is 1122. And initially I will, at the first position, I will keep something. I'll keep either 1, either 2. Only 2 possibilities are there. So if I swap this 2 here, I should not be swapping the next 2 here. I should be swapping only either the first 2, because if I swap the first 2 with 1, I will get 2, 1, 1, 2. And again, if I swap the last 2 with 1, I will get 2. I will get 2. What else? 1, 2, 1. And you can see that these two are duplicates. This 1, 1, 2 and 1, 2, 1. If I find all their permutations, this becomes a duplicate. So I should only pass like the first number of that only. So if I have swapped 2 with 1, I should not swap next 2 with 1. That I should ensure. Suppose in this case, I want to generate it for 1, 2, 1, let's say. Here, first position can become 2 or 1. So I have 1, so you keep it as it is. You can also swap this 2, but if suppose there was 1 more 2, you should not swap there. So somehow you have to remember keep which of the numbers you have already swapped and make sure you don't swap them again. So how do we do that? So maybe we are trying some studies. Let's keep a map of int combined, which will tell whether it is swapped or not. Fine. So I will say if swapped of nums of I, maybe like swapped dot find nums of I is equal to not equal to swaps dot. Means whether if it is already swapped, then you continue. Otherwise, you swap and tell in this map that you were swapped. So swapped dot insert or like swapped of nums of index is equal to let's say 1. Will this work? Let's try. This is swapped. So this one seems to work. Let's try submitting and see key whether do we have some simpler idea. So do you see what we did? Key, if I have swapped it once, you kind of don't swap the number again. So if this number was let's say 1, 1, 2, there were many twos. So you first swap the first two, but then you don't swap the next twos. So if you have swapped some number at the first position, make sure you don't swap the same number at that position again. Is that clear? Hello?
Yes, it is clear.
You can maintain a set as well. That is like, I'm thinking whether can we do even better or not. Do we really need like a set also here? Let's think about that also. So we can do this and let's try running this code. Both of them should be, I think, similar time. Can we do somehow little bit better? So you have to check whether you can even create like a vector also. And instead of set, you can just use vector and swap of let's say nums.styles. Sorry, numbers could become larger. So this numbers, like instead of using map, we could, if we are sure that the numbers of the array num are from 0 to n-1, then instead of using map, we can use an array itself. Do you think any other simpler way of doing this? Keep making sure if you swapped some equal element, make sure you don't swap that again. I don't think there is any other easy way. At least this solution is clear to everyone. Hello? Everyone like at least clear why this solution is working? One thing that you could do is, so let's go to the first solution. You print including duplicates and in the end you remove the duplicates. Can you do that? So if you do this, you will have duplicates as well. So in this case, you have a lot of duplicates. Can you remove duplicates by yourself? So you can pass them in a set result, let's say, and for vector int prompts. result dot insert form, and instead of returning result, you just return the different. So let's see whether this set has a comparison for this or not. Okay, result. Okay, then I have to make sure vector of vector answer for result answer dot pushback and I will return answer. Let's try this. So this one should also be fine. It's not too printing, maybe. Okay, this one was time limit exceeded. So let's remove the printing and then do. Yeah, this one kind of got accepted, but the other solution, when we in the generation phase itself, if you make sure they are unique, that performs better than using a separate set and checking. Is everyone clear with this? Why I'm using a set and how am I using? Anyone wants to comment on this thing? This person, everyone is at least able to see what I'm doing. Hello, someone? Are you speaking or am I not able to hear? Let's try maybe this problem. I'm not sure how hard this problem is. Are you guys able to listen to me?
Yes, yes.
So everyone is fine with this question, huh? If someone like did not get why this having this swapping array worked, let me know, because that is very important. Not sure why it's not showing my older submissions. Anyway, this is a bit weird. Anyway, did you get the idea why I needed to make a set or map of what elements I have swapped and make sure that I don't swap them again? Everyone clear? If anyone wants me to repeat, I can repeat. Because this question is like one of very important questions. If you kind of understand this question, you have more or less understand a very deep aspect of recursion. So are you guys sure? If you want me to repeat, I can repeat again. Should I go ahead with another question? This question maybe? So this question says that the set contains n factorial unique permutations. By listing labeling of the permutation order, we will get for n equal to 3, 1, 2, 3, 1, 3, 2. So you permute them in the corresponding order, and given n and k, return the kth permutation. For example, n equal to 3, k equal to 3, the number is 2, 1, 3. For n equal to 4, k equal to 9, this is 2, 3, 1, 4. So n is like 9, k is from 1 to 9 factorial. So one way is to kind of like generate all permutations, then sort them and print them 9. So maybe like this same code you can use. Let's try. So here, let's try this. Okay. This one will print all permutations. Okay, maybe. Okay, so let's say vector int, I don't know, nums maybe, then result store spec nums. Do you know how to solve this question? You can kind of like directly use the same idea and sort them by putting them in a set, and then you are more or less done. And then you return the, but let's see whether we will be able to pass using that strategy or not. So this is my simplest. So vector of vector int is, let's say, result, and then I'll say recursion. Index is, let's say, 0, and nums, let's say, goes from, and nums goes from n, nums dot push back I, and nums permutations. So let's compile this part at least. So this will give me, this permutations will give me all permutations. Now, because this permutation is not the sorted one, I have to sort this. So let's say sort permutations dot begin permutations dot end, and then I will return the kth. So k equal to 1 means I'm 0 indexing, so I should return k minus 1. So permutations of k minus 1, I will iterate over that and I will just print add that to string. Let's just turn on for each empty string. So for int in this permutations of k minus 1, and answer plus equal to, how do I convert this element into a string? How to convert a number into string? Do you know some function in C++ that can do?
Lexical cast.
Lexical cast. Maybe. Let's try this. Whether this works, I'm not sure. Yeah, there seems some function to string. You are lucky. I just guessing. Anyway, so is everyone clear key what did I do? I just printed all permutations and sort them, take the k minus 1th of them, and just print that. So 3, 3, that seems to work fine. Let's try with 4, 9. 4, 9, my answer should be 2, 3, 1, 4. 2, 3, 1, 4, fine. Let's try 3, 1. My answer should be 1, 2, 3. So let's submit this and see what happens. At least everyone is clear what I'm doing here. Anyone has any doubt? What I'm trying to do here? Let's see. I'm not sure why they haven't shown me anything. So this one is saying time limit exceeded because we have like n factorial, so 9 factorial. So how large is 9 factorial? So this is 3 into 10 power 5, and each permutation contains like 9 integers. So 3 into 10 power 9 factorial times 9. This is the size of this results, this permutations array, and then I'm sorting this. So permutations ki size will be this 9 factorial. So if I sort this array of size 9 factorial, my total time complexity will be 9 factorial times log of 9 factorial, and comparing takes order of n. So this becomes 3, 3, 6, and 7, 10 power 7. Like, it may not tally, but in our case, it is saying that it is getting tallied. So we should do something to ensure that it doesn't get tallied. So how do we ensure that? You have an idea?
while swapping and indexing, giving index plus one, we can ensure here well in order like if 1 2 3 we are swapping first one and then two, and then again we are first position we are keeping one, then two, then three. Then in that case, we can fix first one and then we can swap two and three, and then ahead of this, then I think we can get.
Okay. Okay, interesting. So one thing that we can see, let's decide what will be the first number. So first number will be 1 for if your k goes from 1 to n minus 1 factorial. Then first number should be 1. Is that clear to everyone? Because suppose you fix the first number of your permutation to be 1 in lexicographically order. So if you fix it to be 1, you can see that the remaining ones can be arranged in n minus 1 factorial ways. Fine, because there will be n minus 1 factorial, n minus 1 numbers remaining numbers, and you can arrange them in n minus 1 factorial ways. So the numbers that are starting with 1 will be n minus 1 factorial. Fine. So if your k is greater than n minus 1 factorial, then you have to make sure ki your first number cannot be 1. Your first number will be maybe 2. So you try with 2 and see ki, can you do with that. And if you realize ki no, you cannot do with that, then you try with more. So essentially like this is the idea. Let's do everything. So first do k minus minus. I will explain why I'm doing. So we go from 0 to let's say n I plus plus, and let's try putting I here. So, and let's get a set of, let's do this, fine. So I will, let's go from I from 1 to n. And I have to print kth number. So, okay. So let's go from 0 to n. Let's call it iter. So we will do n minus 1 iteration, and each iteration we will find the smallest number that has not been taken till now. So the numbers that has not been taken till now, we'll try those numbers, and if so basically vector int of not taken. So if nums, or maybe we can just do, okay, maybe let's take num set. If num set of dot find of I equal to num set dot end, it means it's not there. Then I'll say not taken dot pushback. Fine. So here it means these so the numbers in not taken set are the ones that have not been taken. So I will choose one of them and I will try checking whether. So what can I do? So I can iterate over this number not taken, and I can see how many numbers can I generate. I will be able to generate not taken factorial. So if I fix first number to be, let's say, when I was saying fix first number to be 1, then I can do n minus 1 factorial ways. So if I fix first number to this, I will be, so let's calculate factorials also, right? Vector int fact of n, let's say n is 10. So for n I is equal to C1 to I less than equal to 10 I plus plus, let's keep it 11. And let's do factorial of I is factorial of I minus 1 times I and factorial factorial of 0 is equal to 1. So here, the remaining number will be factorial of not taken dot size minus 1. Let's say S is not taken dot size. So this will be factorial of size minus 1. So if your k is less than this, then this is your kind of answer. And if k is greater than this, you subtract that. So what do we do? So if k is greater than factor size minus 1, what will you do? You do k minus equal to factor size minus 1. Otherwise, you append in your answer this number to string of and num set dot insert num. Whatever is in the end is your answer. Let's try whether this works for a simple example or not. Okay, so the answer for 3,3 output is 231, but expected was 213. Okay. My output was 231, expected was 213. Okay, interesting. So let's first do just the first one. Okay, what is the first one? So first one is 1, 2, 3, which is surprisingly correct. Let's try the second one. Okay, so this one is wrong. No, output is 1, 2, 3. Okay, so let's see what is happening. So it did an iteration. So not taken should be all the elements. So I compared with the first one. And so I'm checking what should be the first number. Should it be 1 or anything else? So suppose I put it 1, then my n factorial will become, so I'd find second number. So let's not do this and try it. So my answer is 2, 3, 1. Okay, let's see what is happening. We are making some mistake here. We will figure out what is the mistake. So initially the number is here. In the first iteration, iter equal to 0. The number will be 1, 2, 3. The not taken numbers will be array of 1, 2, 3. And I have to find second element. So I try with 1. So num is 1. So is k greater than factorial of size minus 1? So size minus 1 is like, if I keep first number 1, how many numbers can I make? So I will be able to make 2 numbers. So k should have been, let's print few things here and we will test. Okay, so here output is 1, 2, 3. Because send k to find 0th number. Okay, I don't have that debug utility, otherwise I would have been. So let's print few things. So in the first iteration, what will be value of not taken? This will be not taken. Fine. And size would be 3. So 2 factorial is the number of ways. So is k greater than 2 factorial? 2 factorial is 2. K is 1. So that is not true. So the first number becomes 1. So answer, because the first digit is 1 and we are fine. So in the next iteration, this was for iter equal to 0. And here the number taken was, so answer had become 1. Now let's go to iter equal to 1. Not taken is 2, 3. And so let's try with 2. K is 1 again. 1. And K is 1 here as well. So size is 2. 2 minus 1 factorial is 1. Okay. So if is k greater than equal to 1 is greater than equal to 1. So we are saying at the second position we will choose 2, which is wrong. Why it is wrong? Do you get what is the problem? Here the number, second number should have been 3. But what we are saying here, like I can generate 2, 3 at max one element, 2, 3 itself. And if k is greater than, so fact of k was 1. So this will become 1 minus 1 will become 0. And in the next iteration it will come and it should have taken 2. Should have taken 3. Which is surprising. Okay. Let's print a few things. See out k. Let's print this and see what is happening. I think we should, after doing this, we should do a break also. We have inserted this. Okay, this seems fine, more or less fine. Please. This seems to run fine, basically. It's k equal to 1 and so on and so forth. So let's try n equal to 4, k equal to 9. 4 and 9. Run code. This one also is also. Do you see why this is happening? This not comma is not coming in some cases. Do you see what is the problem? Am I printing anywhere else or is there some problem? Like here in study out comma is not coming. This is weird. I think this would not be plus, this would keep this. So did you get the logic? So let's first submit this and let me try to explain the logic what is here. So the idea is basically I want to find kth permutation. What will be the kth permutation? So first I have to decide what will be the first digit of the permutation. Fine. So if the first digit is 1, I can make permutations from 1 to n minus 1 factorial. So how many permutations with first digit 1? With first digit 1. Can you tell how many permutations are there? Of length n minus 1 factorial. So if your k is less than or equal to n minus 1 factorial, then you are sure that the first digit is going to be 1. Is this correct? Do you agree with this? If your k is less than n minus 1 factorial, then your first digit of computation would be 1. Is this clear to everyone?
Yes.
Do you see why? Because there are n minus 1 factorial permutations with first digit being 1. Or and if your answer is greater than n minus 1 factorial, 2 times n minus 1 factorial greater than this, then your first digit would be
2.
So this way you can like exactly find what will be your first digit. Fine. You can uniquely find what will be your first digit. Do you agree with that?
Yes, sir.
And you do the same thing. With the second digit, you try same thing. So what I'm doing here, I'm building my answer. So not taken is the set of elements that I have not taken till now. I'm iterating over that. And this fact of size minus 1. So in the first iteration, size will be n. So this will become n minus 1. So if your value of k, which number you have to find, if it is greater than this number, then you subtract that. And if your value becomes smaller than this number, then this number itself should be the part of your answer. So do you get this idea? At least you get this idea. If your k is less than an answer, first digit will be this. If your k is from this to this, your first digit will be 2. So this way you can determine what will be your first digit.
Yes, I got this part, but in if condition, when you are comparing the k and the factorial of size minus 1.
Yes.
Yeah, this one. Can you explain this one?
So here what I'm doing, so suppose your first digit is, you have decided if k is greater than fact of size minus 1, then you are sure your first digit will not be this particular number.
Yes.
Because your k is larger than that. So you remove these many number of operations and you start with the next one. So for example,
all the permutation of that particular number which we don't want to.
Yes. So for example, let's just go for 4, 9 maybe. So 4, 9, let's print k, num here. So for 4, 9, you can see k is, initially I did k minus minus because I want to map these numbers from 0. So the first permutation will be mapped to 0, the second to be 1. So I'm using 0-based indexing. Is that fine?
Yeah.
So in the first iteration, what I do, I start with k equal to 8 because k I did minus minus, and I'm trying with first number being 1. So with first number being 1, there are 3 factorial, 6 permutations. So with first number 1 being 6 permutations, if k is greater than 8, I will subtract 6 from that. So with starting with number 2, I just want the second permutation starting with 2.
Yes, I got it.
So the first number becomes 2, and then I try with remaining numbers. I'll try with 1. What happens if I keep the first number 1? Then it becomes 2 minus 2, 0. Then you have to find 0th permutation with first digit being 2, second being 3, and the remaining one you are sure that will be in the sorted order. Like it's slightly tricky, but you get the idea.
And why we are doing break here in else condition after inserting one element?
Yes, because like we have decided this, if you don't do break, then we will keep on inserting the remaining elements also, which is bad, because we are deciding what is the first number that I can insert here. So first it's nothing else, just you should understand what number should be at the first position. If you can understand that, the remaining part is exactly the same copy thing. So for deciding at the first position, I will do, if k is greater than factorial of n minus 1, I will subtract n minus 1 factorial and I will go to the next number. for whichever number this condition is not satisfied. And there will be at least one number for which this condition will not be satisfied. I take that number as my first number. So suppose your number was less than n minus 1 factorial. Fine. Then in first condition itself, you would have satisfied that and you would have taken the smallest number as your answer for the first digit. Clear?
Yes, sir. Got it. Thank you.
So it's just a bit of math. If you kind of like, I can share my code with you. Maybe if you permutation sequence. So maybe you can go home, try running this. So this one was like not related to recursion. This was more of a math question. It's kind of a greedy sort of idea कि what कि पहले digit में क्या रखूं. So this was more of like number theory types idea. Do you have some good backtracking problem? You can try that actually. So this is n queens problem. Should we try this question? What do you guys think? If you are like not tired, we can try maybe this backtracking problem. Anyone? Should we try, or you guys tired? We should like we should call it the day.
Everyone is posting in chat. Yes, you can continue that question.
Okay. So let's see what is the question. So this is a hard level. So n queen puzzle is you have given an n cross n chessboard. So this is in this case let's say 4 cross 4, and you have to place 4 queens. So such that no 2 queens attack each other. So given an integer n, return all possible distinct solutions to this. So the distinct solution would be where should I place? Do you know how do 2 queens attack each other? If they are in same column and in same diagonal, is that right? I don't know that much about chess. Is that right? Like a queen can attack in same row, same column, and in diagonals. For example, this one can go here, it can go this column, it can go diagonally. Am I right?
Yes, sir.
Okay, cool. So I have to find all the solutions basically. Okay, how should I place? For example, in this case, Q is here. This corresponds to this Q. This corresponds to this Q. So I think n equal to 4. These are the 2 solutions. So I have to print all solutions to this. So what is the one strategy? So see, key. How many total squares will be there in this grid? How many squares would be there?
And cross and
Yeah, n times n square is here, na? So suppose I just do recursion over the entire thing. Key at each place, I decide to keep a queen or not. And if I just do the recursion, and in the end I just check whether my configuration is correct, then that time complexity would be 2 power n square. Is that clear? I'm just generating at each place, I decide to keep a queen and proceed this way. In the end, the time complexity will become 2 power n square, because for each position, each cell, I'm trying whether to keep a queen here or not. So there are like 2 possibilities for each cell. There are like n square cells, so there are 2 power n square possibilities. So this will become like 2 power 81, which is like really large. How large is 2 power 81? Anyone has any idea? 2 power 81. I think it should be really large. This is 10 power 24. Will not pass in time at all. So we have to kind of do better than this. Can anyone suggest some ideas? So the other idea could be key. You can see one thing. So see this way. The first queen. So in a single row, there can be only one queen. Is that clear? And in a single column, there can be one queen. There is no other way. Is that right? In a single row and single column, there cannot be two queens. Fine. Everyone fine with that? Hello?
Yes, sir.
No. So what we can do is let's start with first column. In first column, we will decide one of the rows to put queen into. You can put in the first row, you can put in the second, third, and fourth. So there are 4 possibilities to put in the first row. And for the second column, there will be 3 possibilities. So suppose I put first queen in this position, then I cannot put second queen in this position. I cannot put in this position. So basically, if I generate a permutation, and that permutation will tell me if the permutation is, let's say, 1, 2, 3, 4, it means place one queen here, second queen here, third queen here, fourth queen here. If the permutation is, let's say, 2, 3, 1, 4, it means in the first column, place in the second row. So first column, place in the second row. In the second column, place in the third row. In the third column, place in the first row, place here. In the fourth column, place in the fourth here. So this, you can see that one permutation generates one way of putting a queen, but that way may not be a good way, because usme there will not be any 2 queens in the same row or same column, but there can be 2 queens which are in the same diagonal. Do you get this? So if you try putting the queens in this permutation fashion, you can see that you will guarantee that there are no 2 queens in same row, same column, but there can be 2 queens in same diagonal. So this way you have to remove the queens from the diagonal. Can you see how large 9 factorial? That is not much large. So what can I do? I can try all of these 9 factorial possibilities, and in the end I check whatever is the final configuration, is that a valid configuration? Is everyone clear with that or not?
Can you explain it once
Again?
Yeah, please.
Okay. So what I'm saying let's go, I will go from first column to the fourth column. Fine. In first column, I will decide कि किस row में मुझे queen रखनी है. So suppose I decided कि third row में queen रखनी है. Then in the second column, I cannot put queen in this third row. So I'll have to put queen in either first row, second or fourth row. So suppose I decided to put in the first row. Then I cannot put queen in these 2 rows. I can put only in these 2 rows. So essentially, this is same as like generating a permutation, and the permutation will tell, so permutation of length 4, so for example 2, 3, 1, 4. So this permutation tells in the first column, which row should I put my queen in. So in the first row, put your queen in second position. In the second row, put your queen in third position. In the third row, put your queen in first position. In the fourth row, put your queen in the fourth position. This will give you one way of putting your queen. But this may not be correct, because इसमें you are sure that it will not intersect in the row and column, but it may intersect in diagonal.
Yeah, it's intersecting diagonal.
It may intersect in diagonal. So in the end, we have to remove all the ones that are intersecting in the diagonals. Is that clear to everyone? The idea is generate all permutations. For each permutation, you put the queens rows according to the permutation and check whether that configuration intersect in the diagonals or not. If it does not, then add it to your answer. Is that fine? Is this strategy fine with everyone? Hello?
Yes, sir. We are here.
Cool. So let's try implementing this strategy. And we will see what it is. So vector string board, let's call it board, fine. Board of n. Initially, let's say my board is empty. So for I from 0 to this string is empty string. From is equal to dot. Let's say dot correspond to empty. Board is board. So this denotes your empty board of n cross n size. Is that good? Fine. So now I will do recursion in this board. And let's do column. Let's say row. I do recursion in terms of column. I will go from row 0 to row 1 to row 2 to row 3. Okay. So initially I'm at row 0. And let's keep this on it. And let's try to see what happens. And so void recursion. Vector string is my board. And int row denotes at which row I am. So if row is equal to n, then I have I have gone till the end, and at this position, if I ensure that I'm not intersecting with diagonals, then I will be able to show that I am fine. Otherwise, so otherwise in this row you will choose one of the places where you will put queen. Fine. And so which places can you put your queen? So first thing you need to ensure key you can only put your queen in the columns where there is no queen already. So if there is any queen in the corresponding column already, you will be in bad shape. So let's find the columns where there is already a queen. Fine. So what do we do? For int I from 0 to, let's say, so this we have to we can be a little bit careful. 0 I to n, maybe I to row, and for int j from 0 to n, if board of ij is equal to queen. So we have got this is jth column में queen है. Fine. So vector int of has queen, let's say has queen of size n, has column queen. Fine. So has column queen of j would be true. Now I will try from j from 0 to n. I'll try putting a queen here. Fine. So can I put a queen here, which is at row comma I, board of row comma item, board of row comma j पे मुझे queen रखना है. So when can I put a queen here? So this column should not have been already taken. So maybe already taken columns. So in these columns, the queens is already present. So I should not put. So if already taken columns of this is true, I mean there is already a queen. So I cannot put a queen here. So you should do continue. Otherwise, you can put a queen, but what might happen? You might intersect diagonally with some other queen. So at this point, you should check the diagonal intersections. Are you sure that you are not intersecting with anyone diagonally? So how do you check that? Or maybe let's keep it call. So you iterate over your entire board. Fine. So this way I'm iterating over my board. So if there is a queen, how can I check whether this queen at I comma j, this is intersecting diagonally with queen at rho comma col? How do I check? How to check whether queen at I comma j diagonally intersects with queen at rho comma col? How can I check that? Any ideas?
Ratio of their difference should be 1.
Ratio of their difference.
But the rows minus I and by column by I should be 1.
Okay. So one thing you can see, suppose they are from left to right. So one is here and let's say other is here. So you can see that the x difference and y difference is same. So suppose one is here, the other one is here. So delta x is this much, delta x is this much, delta y is this one. So delta in row and delta in column is same. And in the reverse case, if suppose you are here, your row is what? 0, 1, 2, 2, comma 0. So does 2, comma 0 intersect with 0, comma 2? What is your answer? Does 2, comma 0 intersect with 0, comma 2? A queen here, will it intersect here?
Yes, it will, because it's diagonal.
Yes. And will 2, comma 0 intersect with 1, comma 1?
So you can set it
1, comma 1.
1, comma, that's all.
So what is property of the diagonals? So when can I see that two are in diagonals?
If it is the difference of rows and column equal,
Yes, then I can say. So then I can say that they are like going from this way, here to here, this sort of diagonals. What can I say about this sort of diagonals, which go from right to left? So there are two kinds of diagonals now. The ones that go from left to right, left top to bottom right, to bottom right. Fine. For them, I can say कि I comma j will intersect with rho comma col if their difference is same, which is rho minus I is equal to col minus j. What can I say about the other diagonals, which go from right top to left bottom, which is like this way, from this. What can I say about them?
it is also looking like if we will keep 2, comma 0, comma 2 and 1, comma 1, then it's coming differences are same.
No, 0, comma 0 and 1, comma 1 are from this way. No? They will come in the first case.
I'm talking about 2, comma 0.
2, comma 0
No,
with
0, comma 2, 0, comma 2.
0, comma 2 with
0, comma 2 with 2, comma 0.
2, comma 0.
Starting from,
So what?
and starting from, no, it's not.
So it starts with 0, comma 2 and ends with 2, comma 0. So starts here and ends here. So that's fine. So this should intersect, but what will be condition for you? So for this thing, you can see that sum of their x plus y coordinates, that is same.
Yes, sum of x coordinates are, and y is equal to same, but
Because 0, comma 2 has sum 2, 2, comma 0 has sum 2, 1, comma 1 also has sum 2. So these three will intersect with each other. So if row plus call is equal to I plus j, then these two will intersect.
Differences is also working here.
How does difference work here?
Like I have tried 1 comma 3,
1,3,
1 comma 3 and 3 comma 1.
1,3 and 3,1. So what is the difference?
Difference is 2 and both are equal.
This is 2 and this is
Absolute.
minus 2. Now.
Absolute difference I am talking about. Sorry.
But in this case, 0,2 intersects with 1,1, isn't it?
Yeah.
In this
And
case, the difference is 2,0.
no. In which case 0,
0,2 and 1,1. In this case, how will your?
it is also same. 0 minus means absolute difference of x and absolute difference of y. It is equal to 1.
Okay, you are saying absolute difference of y. Okay,
Yeah.
that way. So, okay, see. So you can write this condition, row plus col is equal to I plus j.
Yeah.
So row minus I is equal to j minus col. You see that?
Yeah, got it.
So if row minus I is equal to col minus j or is equal to j minus col. So which means if the absolute difference of their x coordinates is same as absolute difference of their y coordinates, then they will intersect. Is that clear to everyone? Is that clear to everyone? That absolute of row minus I is absolute of column minus j, then they will intersect. Clear? So what I will do, if absolute of row minus I is equal to absolute of column minus j, then I cannot put here. So let me just first denote key at what positions can I put. So let's say vector int and columns. Fine. So what can I do? And if this is true, then I cannot put. And let's say this is n, and I say you can put everywhere. So you can say can put calls of call is false. You cannot put here. Similarly, you say here can put calls of this call is false. Fine. And in the end, so now if you iterate over this, if can put of calls is true, then you can put in that column. So you put in that column. So board of row comma call is equal to queen, and you do the recursion again. Recursion of board comma row plus 1. And after coming from recursion, you reset it to dot, because otherwise in the next it will cause problems. And whenever you enter to the end, what are you going to do? So this is your answer. So you are going to push answer dot push back board, and you are going to pass answer here. So board 0 comma answer, vector of vector string of answer, and finally you are going to return answer. Is this fine? So row is equal to n is a problem. So how is it? Row is equal to board dot size. You can do that. So let's take n is equal to board dot size. Board dot size. Can put columns, it is saying is not. Let's make it to p1 maybe. So can put columns, where are this? Can put.
We are checking directly vector in the if condition of last for loop.
Okay, that's the problem. Thanks for letting me know. So this is fine. So seems like for my solution seems to have worked, which is pretty surprising. I was not expecting that it will be able to work. Let's try for n equal to 1. It's also fine. Can there be any way to place for n equal to 2? Can you place 2 queens? You cannot place. Is there any way in 3? I'm not sure. Let's see. So for n equal to 3 is also not. Let's submit this and see key whether it passes or not. If it does not pass, we will have to think something. So sadly it passed. We can optimize it even further. Do you see what optimizations can you make? Is everyone clear like how we solve this question? We are deciding in each row where to put the queens. Fine. By the way, do you guys kind of, at least do you understand this solution? What I told you? Is everyone clear with this solution?
Yes, sir. Yes, sir.
So if you want to optimize it, you can do following things. Instead of iterating over the entire board in this case again, you can just maintain your position of queens in a vector separately, and you can just iterate over that. So maybe you can do this thing row, comma, vector of pair of int, comma, int. This is queen positions, let's say, queen positions. So this will tell where you have put your queens till now. So what will you do for deciding whether a column is taken or not? So what I'm going to do is following. So let's do one thing.
We can take instead of a pair, vector pair, because we have to traverse that pair. We can take a hash map and integer, where we will directly check that pair whether it's
Yes,
not.
that you can do. But let's do this thing. Pair of int, comma, int. Queen in queen positions. Queen positions. So let's check. Check if queen dot second is equal to column, then I cannot match. It means key. What does it mean? If queen of second is equal to column, means like the column is matching, so I cannot take same column. And I can check whether those two queens intersect or not. So how do I check that? So this condition. That would be if absolute of row comma I would be queen dot first. This would be queen dot second, and then OK equal to false. And here, if OK, I can go to the recursion. So I can remove this entire conditions here. Let's remove these as well. So if OK, then what I'm going to do, set this to the recursion. And in queen positions, what will you do? Queen positions dot pushback, make pair of row comma column. And in the end, you do queen positions dot pop back. And you remove this entire thing. Oh, sorry, what did I do? So you do this here. Remove this entire. So let's try this. What is this? Queen positions we are not passing. Queen positions, and initially let's make an empty vector, which is vector of pair of. So for 3, it seems to pass. Let's try with 4. Like this. And So let's try submitting this one and see how much time does it take. Getting it is almost very similar time, but this code is like much cleaner than previous code. Do you see that? See how this code is like much cleaner than previous code. Can you pass board as a reference? Can you pass queen positions as a reference?
Because queen is a
Yeah, I cannot pass because यहाँ पे मैंने कुछ बनाया नहीं है. Queen positions. What do I do? Will that be faster?
we are able to pass reference as a board because we are not adding or something removing. Only just we are changing the
Changing the corresponding value, and we are kind of like when we do the pop back, we come back to the same previous state.
like in queen position we are doing pop back. That is why it is working here also.
Yes. So final time comes. You can say it has come to 8 seconds.
Means why it time complexity is lesser while using reference. only.
Because because if when you are using reference, the same object will be modified. Otherwise, while making the call, entire copy of the current array is made, and that copy is passed to the recursion.
Okay. That time was taking to creating the copy of that board and queen position. That is why it was taking more time.
Yes.
Oh,
So very like simple way to see that is, let's see some reference example. Let's say how references are maybe a bit useful.
that queen question, queen problem is.
Let's just go very quickly with this. I will come back to queen just in just a second. Fine. So suppose we have a vector int v, fine, and it has size n. Let's say n is equal to, let's say, 10 power 5. And what I do, let's say you have set int st, and I have inserted these elements in the set. I make a function is present, and यहाँ पे I'm passing set and in lm. So this will return set dot find lm is not equal to set dot end. Fine. So then this will be true. And let's try for each of these numbers where they are present in set. If it's present in set comma I, answer plus plus, the answer will be 0. Take the answer. What should be my value of answer? Can anyone tell what will be value of answer? Okay. So set me, I have inserted all the elements, and then I'm checking whether those elements are present in the set or not. So each one of them will be present. You know? So its answer should be 10 power 5. But you can see that it's taking a lot of time. And instead, let's see how much time it takes. Instead of passing set separately, if I pass it as a reference, then you can see how much time it will take. This one is taking a lot of time. That one is like immediate. Because when you are not passing as a reference, then it will make a separate copy of itself for set. So it will copy all those elements before passing to this function. So do you get the benefit of using reference?
Yes, sir.
Because otherwise in each call it will pass this entire thing. So if you are using recursion and your array is like really large, then you should pass that as a reference. Otherwise, it will kind of copy that up. It won't be taking it as a reference. So it will make an entire copy. Yeah, now coming back to question, what was your doubt?
Same you have cleared board because we are giving the reference at board and queen position, and it is taking very less time.
Yeah,
That
it
is,
has become much faster. Okay. So the reason is like,
means only one time it's created the space, and every time it's only just referencing that space, and not
yes,
creating that space every time.
yeah,
Okay.
precisely. So this one, like everyone got these two conditions. These are like kind of very easy conditions. Then we are deciding कि कहाँ पे put करें, and we are calling recursion, and we are kind of resetting like those two conditions, है ना? And ये condition समझ आई? Everyone got this key. How to make sure that the two positions intersect diagonally. Their absolute difference should be equal. If you just compare their difference, you will be comparing from the one-sided diagonal only, from left top to bottom. Right? You have to do both the conditions. You have to take absolute value. This part, very important. Fine. Anyone has any doubt? Is there any backtracking question? Okay, let's try some. Let's not try very hard questions because I think those may not be like that useful. I'll try one that has like simple description. Do you want to try some? Okay, let's try. This is a nice question. Are you guys tired? You want to try more, or we can maybe let me know what to do. Do you want to? Should we try more? One more question, or should we end? Let's see this question. If like more than, how many people are there? 19. If more than 10 people are interested, we will continue. Otherwise, we will stop. This question is M cross N board hai, and adjacent cells are horizontally or vertically neighboring, and we have to find all the words on the board. So in this case, auth, p, eat, rain, only eat and auth exist in this, I think. How does eat exist in this? Horizontally or vertically. So this one is eat, this one is auth. So basically, given a list of words, tell which words exist in this board, and existence के लिए condition ये है कि the words should be either two words are adjacent if they are like horizontal or vertical. So for example, NEAKHFI, this one exists. Word length is from 10 and there are 3 into 10 power 4 words. MN is 12. Let me know if you guys are interested in trying this. We can see in that case. Otherwise, we can kind of end today's lecture.
But I think if we will do in next lecture if you will take it. We will try it our own once.
Yeah, I think this is kind of very similar to the questions that we have done.
Yes, sir, sure, sir. We will try that question. And the previous
Yes.
question, please
This
give us
question.
so that we can understand it.
This queen wala question.
Yeah, Q&A question and you have done all the things.
My code, let me just copy this code. Okay, cool then. So maybe try this question. Try the word search question. This one is nice question. If you are like able to do queen problem, this word search problem, I think these are really good like checking examples. And this one is also very good, Sudoku solver. If you can do this problem, you must do this problem. This is such a nice problem.